Alright, this is our video for the Engineering 1330 final project. My name is Aiden Reese. I'm with
Jose G.
Thomas Nice.
And first we'll talk about how to use it. So this is the model. So it's on Jupyter Lab on a IPYNB notebook. So to run it, you just click on it and click Shift Enter. It takes just a couple seconds to load. And when you're using it, there's these input parameters for all of the ranges that are allowed that'll work and give you a good number. For this example, I'll just use one of these combination features above that we'll talk about in a second, what they are. So it'll ask what they are, and they're the exact same as down here, so you know what they mean. And here, you type it in, enter, surface area, type it in, enter, wall area, same thing, enter, roof area, overall height in meters, orientation, it's between 1 and 4, glazing area, for this example it's 2, it can be between 0 and 0.4, and then glazing area distribution, which can be between 0 and 5. And then after you click enter for the last time, you get your predicted heating load in kilowatts and predicted cooling load in kilowatts. This works with any integers or floats, but any strings or empty strings would not work. It would cause an error. And here's those ranges right here.
Yeah, we would like to mention like the inputs are pretty. Their range is pretty restrictive. So if you enter a value wrong, it'll completely give you a value that's way out of range. That's pretty
Yeah,
much like invalid or indeterminate. To which so you have to be careful with entering the values that actually make sense with the model.
yes, so since everything's trained off the data set we were provided in our instructions, anything too like crazy far off from this will cause a very skewed number that doesn't make much sense. But that's how you use it. Now we can move on to project management, and we can break down who did what and what it is. You want to start, Thomas?
Sure. So I'm Thomas Nice. I mainly wrote the literature review, and I also researched and implemented the sklearn modules, as well as just researching in general for the group. And that's mainly it. I read over code and I reviewed things as well.
And as for my part, I'm Jose G. And basically, my part of the code was basically taking from our training data, the linear regression equations using the modules from sklearn, and we extracted the coefficients and each of the intercepts for the heating and cooling equations in order for us to build the user interface and predict the proper quantities for the loads of the heating and cooling. And that's my main job of this project for the most part.
All right, and then I just so firstly, I worked on these graphs. There's a bunch of them. What they cover is heating and cooling load for feature importance, so what'll affect the outcome the most for the load. The actual versus the predicted load, so basically how close the predictions we get are to these numbers right here on the data set. Error distribution, just error distribution between these, just like pretty much the same as this. And then a heat map, which is another way of viewing correlation and symmetricity and skewing. and then residuals for heating and cooling. And that's all. It's all through here, as well as just some extra like little things, feature combination stuff, user input down here for typing everything in, getting the output, and RMSE and R2 factors.
I'd also like to mention that I did also some in part with the interim report about the just overall overlooking code and making sure everything runs well. Do some even some debugging as well where it's needed, and fixing some errors that occurred during the process of this project.
Right. And then we all kind of just worked on getting it to actually work and look nice and be usable. But other than that, that's our project. Anyone else have anything else to add?
No, sir.
No, sir.
Awesome. Thank you.